Hey, curious people, have you ever wondered how the eye works and how the eye achieves vision? Like, is it just a squishy camera, or are there some really weird and unique differences? Let's take a look at the components of the eye, how they work together to do their job, and some weird implications of that, and how it actually is quite different from a camera. Let's jump in.
The human eye, the window to the soul and round fluid-filled ball with a hole in it. That hole, that's the iris, dynamically controlling the brightness of light that passes through the cornea and the lens, and controlling the intensity of the image that lands on the back of the eye. In the inside wall of the eye is covered in a sheet of cells called the retina. This is where the magic happens. There are cells called cones which react to different wavelengths of light and let us see color. There are also cells called rods that react to the intensity of light and give us our excellent night vision and enable us to see in low light conditions.
That all checks out. The eye reacts to light just like a camera, right? Not really. The sensor of a camera is laid out quite evenly and all the sensors are evenly distributed, whereas the retina, the cones are randomly distributed and the rods surround them. The cones are only really in a very tight portion of the eye called the fovea and the macula. And this has some implications for the types of things you can see and how you see.
You can hold your arms out at arm length and stare at the tip of one middle finger. And without moving your eyes, no cheating. Describe the alternate finger. One will be crisp and the other one will be quite distorted. Your fovea only really has about a 2-degree slice of your field of vision. The rest is not very high resolution at all.
The eye is being frugal versus a camera. It is constructed of these parts, rods, cones, and the fovea, to feed the circuitry hidden within.
The retina is doing some serious compression on what we see. Beyond rods and cones, the retina contains other cells, the ganglion cells, which merge, inhibit, and invert signals of the individual rods and cones. It doesn't send information if there is a static solid color. By doing something called center on keying and center off keying, the eye can only send edge information to the brain for each color. Sit down and draw something with a pencil. You'll draw it as solid lines. Not all that different from how your eye analyzes image data. Well, you choose to draw lines to represent something because they stand in for the shadow of light to dark or vice versa. This is what the eye algorithm is all about, finding edges, so you draw it that way. In the end, the eye sends 6 different simultaneous streams of edge detection to the brain. 2 for each color and sometimes others from monochromatic rod vision.
See this example of an event camera for what the signals from the eye might look like. That fading is probably a bit fast compared to the eye's real adaptation rate, but that's definitely the idea. The eye is weird. Its processing is very targeted and very frugal, dispensing unneeded information in time and space. An important takeaway from this for artificial vision systems is processing resources are expensive in biology and shouldn't be wasted on the unneeded. One step from my Pi car is to implement something like this event camera on the car, so only essential data is leaving the car to be passed up to the eventual cluster computer to be analyzed. That frugality has implications for our perception too.
The eye is not a camera, it's a processor. The first step in the ultimate model maker that is the brain. Another game you can play to convince yourself of this, that you don't see the world directly, is to think about hallucinations and optical illusions.
Not all of what you see in through your eyes is what you perceive. Sometimes lines are different shapes or sizes. Sometimes images are superimposed. Sometimes the images move around when they don't. But it tells you that your eyes and your perception are separate. And your eye can be damaged and you won't perceive through that circuitry in your eye exactly what's going on. Macular degeneration is a hole in your eye and your vision can have a blind spot, but you won't know because that's not how the vision circuit works. You have a hole where your optic nerve is, and that is not perceived by you when you take in the world. Let's recap here about how weird the eye is. It's made of some basic components from rods and cones and some other cells underneath, like ganglion cells. And that strange circuit is very frugal. It does not pass off any information that it does not need to. It's looking for edges information and movement information, but nothing else. And that results in a really strange outcome, is that what the real world is, what a camera would do taking a perfect replica, is not what the eye does, and results in some very strange things for perception.
All is not as it seems. I hope this really raised a few curious thoughts for you. If you want to discuss more on the eye as the first modeler, please comment below and let's have a conversation. If you're curious about how the biological eye relates to machine vision, computer vision, check out the next video in this series. Happy creating, and see you next time.